À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage.
Well, we are underway. Did you watch the arms pull back as scheduled? And did you count to 7? After those 7 seconds, a slight wait, and then boom, away we go. You saw Ariane 5 begin her mission, rising off the ground here in French Guiana, leaving a trail of gold, and right on time. 1834 local with her 2 passengers, Arabsat 6B, also known as Badr 7 and GSAT 15. The boosters are providing 92% of the thrust right now, propelling the launcher along its trajectory at an ever higher velocity, getting her away from the pull of the Earth. And there is a lot to pull. Ariane's weight at liftoff, 775 tons, and most of that is fuel. She's burning 2 tons of fuel per second. She's now following the flight program in the onboard computer, which gives all the commands, including the separations. We'll soon begin to see those. We are in the first of 4 flight phases. The first 3 are powered, the last is not. We'll describe each in turn. Right now, the first flight phase, the Vulcan engine and the 2 boosters are burning. The boosters will burn their propellant in just under 2.5 minutes. They're the first that will be jettisoned. You'll hear the DDO call out that milestone as he calls out right now. Everything is okay on board. We're heading east, out over the Atlantic. The decision to build the site here in French Guiana, made in the 60s when France wanted a new base, was in part made for its opening on the water to allow for launches over uninhabited areas. On the bottom of your screen, our altitude on the left and our speed on the right. We need a speed at orbital injection about 9 kilometers per second. Our altitude will be about 1,000 kilometers up for our first passenger, so watch for those numbers. You just saw the flame out of the boosters. You can see them falling away. The white dot below them is the main engine, which continues to burn. You can see what it looks like up there. The boosters are jettisoned. There's a second one out of camera range on the left. What happens is the onboard computer detects there's no more fuel in the tanks. As they have no more propellant to burn, thrust decreases and the computer senses the drop in acceleration, decides to separate them. A nice shot of the main stage burning and the 2 boosters falling away. 3 points of light as the DDO calls out all is okay on board. We say 67 kilometers altitude, for instance. That's the altitude where the boosters were jettisoned. Sometimes it might not be the figure you see on the screen. This is quite normal due to a slight delay in the telemetry coming in here. Coming up on separation of the fairing, due in just about a second or 2. And you'll see that on the animation. You may be able to see it on the camera that we have here. There it is. You see the other 2 points of light falling away. Wonderful shots. The sky is just so clear tonight. On the onboard camera, you see what happens there. There's another half out of camera range on the right. Separation is given by 2 pyrotechnical systems. One is horizontal, one's vertical. They're cords that actually remove the fairing by a small controlled explosion. With the fairing gone, you have exposed to the elements Arabsat 6B. Underneath that, a black bell-shaped structure, which is called the Silda. That's a carrying structure, which houses our second passenger. Underneath that is GSAT 15. We can separate the fairing now because we're out of the dense layer of the atmosphere. Over 100 kilometers up, there's neither friction nor heating, which could disturb the passengers, so we discard also any dead weight. The fairing weighs over 2 tons. And it's lined, by the way, with acoustic panels that protect the satellite from the noise of the engines at liftoff. Our speed is what's important right now, which is the role of the main stage. Cryogenic propellant not only highly efficient, but provides a push that can last for a long time. There are different propulsion systems on Ariane 5. Cryogenics, as used in the main stage, are more efficient than solid propellant, which is used in the boosters. Basically, solids are for getting us off the ground, away from the pull of the Earth, while cryogenics are for more precision orienting of the vehicle. And of course, they allow a stage to be reignited in another version of Ariane. On the right is Arabsat 6B. Below that is the Silda. Below that, the white bands were the vehicle equipment bay and the upper stage. And below that is the first stage. Ariane 5, the heavy lift launcher, 2 other members of the family Soyuz lifting middle-sized payloads, 2 and 3 tons, and Vega, a 1-ton light launcher. We're going to go to our first replay of shots of liftoff. Happened just 5 minutes ago. Always exciting to relive those moments of liftoff. We have cameras at several of the half-dozen observation sites that are stationed across the base here, and they furnish us with shots from different angles. We should be getting their footage in just a moment. Some figures. This is the 83rd mission for the Ariane 5. The two passengers are the 168th and 169th satellites to be launched by Ariane 5, as the DDO continues to say all is working flawlessly on board. They are also the 401st and 402nd satellites to be launched on a version of the Ariane launcher. Remember, the program began with an Ariane 1 in 1979. It flew until 1986. Ariane 2, the first upgrade, was in service from 1986 to 89. Ariane 3, even more powerful, worked from 1984 to 89. And Ariane 4, the real workhorse, flew from 1988 to 2003 before being retired. Ariane's radar and telemetry signal in about 30 seconds is going to be picked up by our first downrange tracking station. That's at Natal, over the border in Brazil. Natal will see the lower stage burnout and separation of the lower stage, as well as the upper stage ignition. All of Ariane's trajectory has been designed to be followed from the ground. The launcher is sending radar and telemetry back and a network of stations keeping constant watch on the health of her systems. Telemetry being the launch vehicle data, information on 1,500 parameters being collected and transmitted back to these ground stations. Every second, they're being sent by 2 transmitters inside the vehicle equipment bay and by the antennas which lie outside. These include indicators of Ariane's health and performance in flight, and they come from pressure and temperature sensors which record all her functions throughout the flight. And what do we do with all this information? Well, some of it is analyzed in real time. Customers get immediate information about their spacecraft, which is important. Other data are analyzed after the flight to learn how the vehicle has performed. A complete analysis is carried out about a week after each launch. You can imagine the enormous archives this gives Arianespace, a wealth of technical information going back to the very first launch of Ariane 1 on Christmas Eve, 1979. We are awaiting confirmation of extinction of the first stage. You will see on the left the blue flame on the cartoon animation. You'll see that die down. You'll hear the DDO, of course, call out that milestone. The Vulcan engine, roughly 50 centimeters, weighing 250 kilos, can generate with the boosters enough power to launch Ariane 5. Remember, over 90% of the initial thrust is provided by the 2 boosters. There you saw the first stage engine shut down, right on time and announced by the DDO. And there's the separation of the first stage. And there you saw the ignition of the upper stage. All these 3 commands given by the onboard computer in about 12 seconds. The main stage, as you can see, separated and will fall back into the Atlantic off the coast of Africa. Up in space, all is working fine on board Ariane. Our speed approaching 7 kilometers per second. Our altitude over 170 kilometers per second. With separation of the lower stage, Ariane 5 has used up all of its 175 tons of propellant. She now loses another 14,000 kilos of dry mass, bringing her total weight down to 25 tons from the original, remember, 775 tons.
Tous les paramètres à bord sont normaux.
We're now in the third and final powered flight phase, a 16-minute burn for the upper stage. It'll burn until plus 24 minutes and 56 seconds. Job of the upper stage is to take the satellites to their injection point, position them for separation, and release them into space. She has another job. We'll get back to that in a minute. But for now, over to Arabsat's CEO for a word on the satellite.